Hello and welcome to NPE 2024. I am Aaron DeLong with HP. I am the Mobility Segment Manager. I'd like to take a little time just to talk to you today about what's going on in mobility and automotive specifically. With that, let's get started. The first question I'm typically asked from an OEM, from a customer, from a tier one is what applications can I implement now? That question comes up pretty much every time. What can we do and why? What applications make sense? What applications should we avoid? What we believe a good answer to this question is something that doesn't exist in the market today. Why? Well, using AM to explore market segmentation, new ideas, new products, new components inside of the automotive market is really, really powerful. And to really talk about that, we need to take a step back in time and look at when did 3D printing start and why? Who adopted? When did they adopt? And what was the value? So with that, we want to take a look at the Automotive Sandbox. This is Ford Motor Company. It's on their website. You can go there. There's a link. Be happy to share that link with you. But 1986, 3D printing, stereolithography, Ford Motor Company brought printer number 3 to be able to utilize for prototype and investigations. And what did that result in? 500,000 parts have been printed so far, billions with an S saved. Again, this is Ford's own words. Check out their website to see this, but also what other industries really started to adopt 3D printing. Well, mobility was a huge segment, so doing a little bit of research online, you can take a look at who bought which components, which printers to start with. So Precision Cast Part was the first machine that was sold after the betas. That was the first consumer machine. Number 2 was actually Electrolux, an HP customer, so Prototal in Sweden. Number 3 was Ford Motor Company, and I believe number 4 was actually another automaker in Asia. So this is kind of our automaker journey from 3D printing standpoint. What do they utilize these tools for? Well, they always utilize them for prototype. It's really the first love of the industry. Prototype parts, things that didn't exist before. Being able to create a part to replicate a part that you're going to create in injection molding. Again, we're here at the NPE show. We have people come by the booth constantly. What do? We mold parts. Perfect. How do you use additive today? Well, we use them for prototypes. Awesome. But what's changed in additives since then? Can we start going into production? Can we start looking at really the next steps there? So let's take a look at that. Again, an example from Ford, an automaker's journey. This was shared at Rapid 2022 by Ford Motor Company. I believe it was Giuseppe that shared this. But going all the way back into the 80s when they purchased printer number 3. You go from there into modeling, sand printing, metal printing, but then if you notice in 2022, they were also pushing into production parts. So we see automakers pushing into production parts on a daily basis. If you look at our timeline for on-vehicle applications, it goes back to 2016 when we launched the printers, a little bit of investigation, a little bit of knowledge, and then we get into 2018, and BMW actually released their 1 millionth part printed. And the image that was used for that was some of their technicians pulling a i8 window guide out of an HP printer. I love that image. But you can see our automakers since then have really been producing every year and new applications. Some of them are on-vehicle production applications, some of them are aftermarket accessories, but still through the automakers. But we get every year new applications, new automakers are releasing PR information on what's new, what's exciting, what's coming up in 24. We're actually looking forward to the release of the Cadillac Celestiq. GM publicly announced 115 additive parts on that, so we're excited to see which parts, which manufacturers. HP was mentioned as one of those suppliers of the technology for that vehicle. But why now? What's changed since 1986? Well, this is a 3D Hubs graph of all of the different technologies across the industry. What's different? Well, one, here's HP. What's different now? Really, it's about the product capabilities. It's about the material price, and it's about the material selection. So you have this convergence of material properties, the cost of those, and the equipment to produce them. That's really what's changed. So again, being here at NPE, what's important to a molder? What's important to someone that owns a tool? Having worked in the automotive industry for 20 plus years, you got to the point where you were finished with your design and you're getting ready to kick off molds. There was always last minute changes, and you really had to manage those last minute changes versus ordering steel. And if you looked at a timeline, this is kind of where you're at. That piece in the center is your tool kickoff. Your design's done. Sometimes you actually order your block a couple of weeks early, but as soon as you put that order in, it's cost of money. You've spent that money, a third of the cost typically to be able to buy the block, a third to start doing the CNC programming. And by that time, your design is locked in. Because you have to produce parts for testing to validate your design, your DV. So that tool kickoff, that's really the lock-in point. What we want to do is we want to push that tool kickout as far out as possible. So just a very simple graph of that. Here's our tool kickoff. What do we want to do? Well, we'd like to shove that tool kickoff a little bit farther to the right. Why? Money. It's a lower cost if you do that. Your cost of money doesn't start until you kick the tool off, but you still have to do all the testing. So if you just shift the tool kickoff, all it does is extend the waiting period from your design freeze, and you're going to continue doing design iterations. Maybe you catch some design issues, but what you really want to do is get rid of that waiting period, and you want to be able to put in some type of additive prototype program or process in there. What that allows you to do is allows you to start testing and doing change loops to validate your designs. Early testing, first builds with prototypes, with additive manufactured parts, do your fits, do your initial builds, maybe even do some of your testing. Great example of that. A company called Cobra Aero. They're in Hillsdale, Michigan. They make motorcycles for kids. I love their slogan. It's where champions start. What they've done is they've come out with an electric motorcycle. So the piston engine side of things, they've already excelled. There's a new e-bike series. That company wanted to be able to enter that market, but they wanted to do that as effectively and quickly as possible. This is where MJF came into play. They use those MJF components on vehicle, on test bikes to iterate their design quickly. They could have a part come off the track, make design changes, have that part in hand the following day, put it back out on the track, test the updates, and make another cycle of design iterations. Now, Cobra actually has internal tool capabilities. They have CNCs, they cut their own tools. But the point here is they're not going to cut a tool until that testing and iteration is complete. And when the time is right, they'll cut a tool. They'll make it with injection mold materials, but they already have proven out the design. Now, that bike is on the road right now. It's available today, and we had it 2 months ago at the Additive Manufacturing User Group Conference, AMUG. It still had MJF parts on it. Why? Because it made more sense to produce them with the additive process than actually cutting the tool at that point in time. So the bikes are on the road today. The other piece is something that doesn't exist. We talked about that. So reacting to industry changes, reacting to new regulations very, very quickly. Great example of that, the GoPro mount. So Sean's team was able to put together a GoPro mount when the regulation changed where you could no longer mount your GoPro to your helmet. It was a safety concern. If there was an accident, there was a possibility that that GoPro could rupture the helmet, create additional injury to the rider. So from that standpoint, they wanted something that they could quickly react to. Sean was able to model up this new GoPro mount and offer it to his customers. Position was already located on the motorcycle, front of handlebars, right on the top of the fender, still be able to record the race so that you can then go back and watch it and get the feedback without having that GoPro mounted to your helmet. So great opportunity, great examples of why additive not only complements but enhances an injection molding tool and how it allows you to react to industry changes. It allows you to prototype your design, iterate, and optimize, perfect your design before you cut a tool. And it allows you to continue in production if you decide to go that way. The other piece, if you've actually proven out your designs with additive, you've tested your designs with additive, after you cut your tools and your vehicle's going out of production, your motorcycle's going out of production, all your spare parts can now be produced without having to hang that tool again. Again, my name's Aaron DeLong with HP. Thank you from the conference here in 2024 in Orlando.